So my name is Marcia Sellos-Moura from Orphan Technologies. Thank you, Mark, so much for the introduction. Also, I would like to thank HCU Network America for the invitation and for putting together this wonderful conference, and a special shout out to Danae for making everything very easy for speakers. So let's see, that's me. And I would like to dedicate this presentation to Dr. Krauss. Dr. Krauss was a biochemist, a professor at the University of Colorado, who dedicated his entire career to the study of homocystinuria. He passed away in early July, and he'll be very missed. So he was Orphan Technologies worked closely with him, so he did all the research that we are taking forward was done in his lab. We then took on and partnered with him to do the development, but he was still very involved and extremely helpful even in the development phases. We had weekly calls with him, so wonderful person, very knowledgeable, very humble. He will be very missed. All right. And I would like to also let you know, I'm about to talk about the natural history, and it's for classical homocystinuria patients, but also it's an ongoing study. So I want to explain that whatever I present, it's still ongoing, so numbers may change as we find more things. You know, it's evolving. So just to know that this is not the end all, but it's a sneak peek. So you've seen this slide many times in different formats, but I think it's always good to go back and kind of remind people. And if I walk here, it's okay? Am I tied? Yeah, I am tied, okay. I won't walk too far. So as you can see, as you all know, when you eat food that has protein, and it has one of the building blocks is methionine, an amino acid. Methionine gets converted to homocysteine, and in classical homocystinuria, it's that enzyme called CBS with the X down there that is faulty. And the conversion of homocysteine to cystathionine and later to cysteine is what is affected. So in classical homocystinuria, there is an increase in homocysteine, and let's see how far I can get without tripping this up. And the blockage at the CBS level means that you accumulate homocysteine and you accumulate methionine, where the cysteine and cystathionine are less, there's very little of it made. So just keep that in mind as I discuss the study.
So you can walk around.
Okay.
You got a pocket?
No.
Any pockets?
Maybe.
Can you put this
Women
on?
never have pockets.
That's right. You can put this on your belt here. Can you do that?
Perfect.
And let me adjust this if you don't mind. So it stops
Not at all.
moving around. Let's see here. And let's go right up here. And I'll be able to edit this out for you, so you don't need to worry about that.
Okay.
Just make sure this looks good there. Tuck this in there. And now you can roll. Just wait for
All right. Thank you. Okay. Good? All right. So as you all know, HCU can lead to eye, skeleton, brain, and blood vessel disorders problems. This is a nice summary, and I want to take the time to emphasize that classical homocystinuria, as pretty much many rare disorders, is a spectrum disorder. So just because everything is listed here doesn't mean it will happen. It doesn't mean that everybody will have all of these symptoms. They may have one or several. They may be mild or severe, and you could have a mild one for something and a severe one for another. So everything I'm going to be discussing is they're averages. So it doesn't mean everybody is going to have this. So just keep that in mind. A little history, I think, is always, at least I find useful. So the CBS enzyme that's affected in classical homocystinuria was discovered in the early 60s. And it wasn't too many years before that that classical homocystinuria was even known to be a separate disorder. So by 1985, it had not been too many years since more was known about classical homocystinuria. And there was a groundbreaking study from many leading experts, including Dr. Mudd, who did a retrospective natural history of homocystinuria. So what they did is they sent, I believe it was paper questionnaires to all the clinicians in the world they knew who treated classical homocystinuria. They also looked at all the publications that were known, there weren't many, and came up with 629 patients to categorize. And they asked many questions, and from that they tallied how many patients had different complications. And they divided things up by, were patients mild in that they could respond to vitamin B6, or more severe and they didn't. Roughly, I mean, this is an oversimplification of a lot of work. In 1985, looking back, remember, even 20 years before, few people even knew about the disease. A great majority had had lens dislocation by age of 10. And a third to two-thirds have osteoporosis by age 15. They were significant mental impairment on average, and this was a little bit tricky to count because most of the patients had not had an IQ test or anything like that, so physicians reported. And also thromboembolic events by age 15 were not uncommon, and newborn screening was detecting patients but not very efficiently. So, let's go 30 years later, into 2016. We decided to do a natural history, but what's called a prospective natural history for classical homocystinuria. There are lots of, well, I shouldn't say lots. There's not that much literature papers on classical homocystinuria compared to other disorders, excuse me. So not enough is known. So some studies have been done throughout the world. Most of them, some excellent, but most of them were in a single hospital, in a single country. And in countries that had primarily one type of what's called mutation, so defect in CBS. So although the disorder is similar, there could be differences. So Qatar, Ireland, they tend to have one type of mutation. And there's also a group called EHOD from Europe who is collecting information on homocystinuria patients from all over the world in Europe and a few outside of Europe. And we're looking forward to their results, and that's going to be also groundbreaking. But in the meantime, we decided to start our own trial to understand what the natural history of patients look like. And this is a trial where people enroll, and then the same types of evaluations are done for everyone every 6 months. The same labs are testing, so everything can be compared as much as possible to each other. And no treatment is given. So to date, we have enrolled 58 patients. We have 3 countries and 8 hospitals. One is right here in Indiana. I don't know if Dr. Hainline is here or his team, but also DC, Dr. Chapman, and Massachusetts, Pennsylvania, Georgia, and Colorado as well. We also have Ireland and UK. However, the majority of patients have come from the US, which is great. We need that information. And as I mentioned, this is an interim data analysis. We've presented in 18 and 19, and we continue to analyze the data, and as soon as we have it, we will publish. We believe strongly in giving back to the community so everybody can benefit and understand as much as possible.
Marcia, they may not understand that they are on treatment, it's just no change.
Yes, thank you, Margie, for that. So no treatment is given, meaning nothing additional from the standard of care. So for example, if we ask patients to continue whatever they're doing to do, for example, the special diet. If they take vitamin B6, continue, betaine, continue. So very good point, Margie, thank you. But it's not an additional treatment, it's not an investigational treatment. So, and another reason to do this natural history is to better understand, to lay the foundation for a treatment clinical trial, which Mark alluded that we have started, and I'll touch briefly tomorrow, I think. But people need to, there's not as much literature in homocystinuria as in other diseases. So it's really important to understand. It's also very important to understand whether what you're measuring stays stable, for example, or gets worse or better with time. If that's called reproducibility as well, whether you can rely on a measurement. Is it going to give you the same result if you do it 3 times in a row? That would be good. So there's a lot that wasn't known. And so as I talk, I'll discuss some of this. So every 6 months, patients undergo several tests. And again, they stay on whatever treatment they are on, they've been prescribed and they're doing. The very first visit is a lot of what we call baseline, the first measurements, but we also do genetic tests. If patients don't know what their mutation is, we do that. And then we collect the diet diary, the food log for 3 days prior to each visit, medications that patients are on. At the very first visit, we also collect the medical history. Anybody in the family has had this, or also when people were diagnosed and how and why, newborn screening or something else. In between visits, we also collect any new information about new eye or bone or anything that could be related to the disorder. I mean, we don't need to know about colds or anything like that, but if it's likely related, we want to know. We do blood tests. Those definitely all the metabolites of sulfur metabolism, like I mentioned, the homocysteine, the methionine, et cetera, and many others. We also do tests for what's called biomarkers. So biomarkers are something that you can measure easily in the blood, so it's not too hard to get some blood. And it could be indicative of what is going on inside the body. So it's a marker. It's an easier way, perhaps, if we can find something to understand progression or not. For example, cholesterol is a marker it could be a marker of many things, right? So we do that for cardiovascular, osteoporosis, inflammation, et cetera, et cetera. We also do perhaps more than, in some cases, than standard visits. So that's potentially a benefit that people get additional testing. The DEXA scans are for bone density. I'll go into more detail. The NIH Toolbox is for cognition / how people think. Eye health, a very comprehensive eye exam, and growth and development. So what do our patients look like? I think on average, maybe the patients that are in our study are younger than the overall population, partly because we are in children's hospitals, but that's where the centers of excellence tend to be. There are also, so on enrollment, patients have been 5 to 53 years of age, but the median age is 21, meaning that half the patients are younger than 21 and half are older than 21. And, but there's a nice balance between, as you can see here, adults and children. So green is children. Also, we didn't set out to do this, but there's a very nice balance between male and female. And the majority did not have a family history of homocystinuria, although many did. Newborn screening, as already been described, and I'm sure there'll be more, is not picking up the, it's not picking up the more than the majority. It's not really picking up the majority of patients. So, and to give you a little bit of background on the newborn screening, so keep in mind, half of these patients are 21 and under. Newborn screening started in the US in different states in different years. The entire US had to have screening for homocystinuria in 2006, but Massachusetts, for example, started in 1967. In Ireland, also they've had newborn screening for many decades. And UK, although they started only recently in the entire country, the site that the hospital that we're affiliated with started many decades ago. So it's been around. And unfortunately, although it's wonderful when it does detect patients, there's quite a bit of work to be done, and I'm sure Margie and Danae would have a lot to say on this, but we need more of it and better newborn screening for sure. So the patients who, as I mentioned, who enroll are very motivated. It takes extra effort to come in every 6 months and go through the battery of tests, schedule everything. And they're receiving excellent care. So these are centers of excellence. And again, not all the patients are going to be receiving such excellent care. And it looks like most patients are attempting to follow this care. So what we do is we ask what medications they're on, whether they're taking the methionine-free amino acid mixture, the vitamins, betaine. And from the food logs, we can see who is following a natural protein restricted diet. And these percentages may be a little bit of an overestimate because, as we all know, every day is a bit different. And it's all self-reported. But overall, adults and children are all trying very hard to follow what has been prescribed and take what is being prescribed. So there's some good news. Since 1985, lens dislocation is, at least in this population, very few patients have had it. So remember back to 1985, it was the majority had been diagnosed, had it by age of 10, not in this. There are ocular deficits, but most patients, but myopia seems to be the most prevalent. However, something that's not so hopeful is the exceedingly high levels of homocysteine in this patients, again, who are trying really hard. And this is not, these are not ordered by patient, by visit, anything. It's chronological. But if you can read from the back, and if you remember the normal levels, depending on your age, is about 10. 10 is about here. Some of these patients have 400, 350, 250, and the great majority have very high numbers. And it's, again, getting all the best care, doing the best they can. So that was a bit surprising how high the levels were. And so here are some of the metabolites that I discussed, and not all of them. So again, if you look, blue is high, normal is yellow, and this orangey color is low. So as expected, homocysteine is high in almost everyone. not unexpected. And cystathionine, the product of the CBS enzyme, is low in almost everybody. Other things that we can, so not only do we collect whether patients are taking betaine and vitamins, but we also measure it, and which is very good. Most patients are normal or taking a little bit more of vitamin B12, which is good, and they're all doing pretty well on the vitamin B6. And then betaine, many patients are on betaine, and we can measure it in their blood, and DMG is related. So. And these are not percentages, these are number of patients. One thing to point out, though, is the methionine levels in some of these patients can be exceedingly high, and that's something to look into. So these are some of the additional markers, these biomarkers that we're measuring, not all of them by any stretch. And again, keeping with blue being high, yellow normal, and orangey low, a lot more normals are present here, which is good. There's some areas that we're looking more into, such as, for example, creatinine. Let's see if I can read some markers of inflammation, and perhaps some markers of liver dysfunction. So again, this is all very preliminary. It doesn't mean everybody has this, and elevations can be very high or just borderline. So keep in mind, this is preliminary. But there's some, we're looking into some additional markers. So something else that we measured are the DEXA scans, the bone density. And some of our patients have had 5 visits, so we have 5 for them. Some have had 1 visit, so we have quite a bit of data by now. And first of all, it's very reproducible, which is great. So we can rely on these measurements in the future. But and again, keep in mind, these are all averages, not a single person. The actual range would be much broader. Some patients don't have osteoporosis, and some have fairly severe. But on average, if normal is defined as a 0, and this is what's called normed for age and gender. So you're comparing a 5-year-old to a 5-year-old, not to a 65-year-old. So in general, and these are hip, spine, and body, most patients have what we're calling skeletal fragility, and children, unfortunately, are not doing much better than adults. Keep in mind, again, half of our patients on this study are under 21. And we're looking to, so it's known from the literature that this is a common occurrence, but we're trying to understand what may also be leading to this. Scientists love to do correlations, looking at, if something is low and something else is low, is this related in some manner? And we're still investigating whether there are additional factors that may be leading to this. And again, there's not a lot of information out there about these processes, so we're all trying to just learn. Let's see. I don't remember if I mentioned this in the beginning, but it's a good time to remind everybody, I'm a scientist, not a medical doctor. So we have Kim here if you have those types of questions. And then finally, we did some of the other assessments we do is this called NIH Toolbox, cognitive battery. It's a fancy word for an iPad with 10 different activities that either a psychologist or somebody trained gives. So it's a very controlled, and it's also done every 6 months. And in the literature, papers have been published, if it's done, what people do is IQ testing, which is good, but it's not everything, because IQ, we all have, we're stronger in something and less strong in other things. And then when you do an IQ test, different types of intelligence, I guess, balance so that you can get a score. But you don't really know what's underneath, right? So what processes may be better or less good. So cognition is just a word to refer to the process of thinking, how you identify the knowledge, how you understand the knowledge, how you perceive and process the knowledge. And I'm oversimplifying this, but overall cognition can be divided into fluid and crystallized. So fluid is how you manipulate that knowledge to learn new things, and crystallized is what you already know and how you can use it. And it's, again, oversimplification. So to my knowledge, this is the first time that it's been done for classical homocystinuria. And also, NIH Toolbox was made by the NIH, taking a lot of previously available tests, and they also did a lot of what's called validation. So they looked at a lot of people of the same age, and they compare. So again, 5-year-olds are not being compared against 65. They're being compared same genders, same age. So it's as good as it gets, I think. So from that, and not to give you literally 100 different charts, because there's 10 different tests that are done, what we found was that better cognition overall was definitely associated with lower homocysteine levels. That is not new. This has been seen before. Also with lower methionine levels, which might be related to the fact that lower methionine often relates to lower homocysteine. But again, we don't know. Crystallized cognition seemed to be just fine in general. Again, everything's in general. But it's the fluid cognition that seemed to have the biggest effect from the higher homocysteine levels. And there are other things that might also be affecting it, but homocysteine stood out. So what does this mean in the day-to-day world? This means that some of the common difficulties could be being distracted, easily distracted, or more impulsive, or maybe having to read something more than once to understand it, or having to come up with new ways of learning. And one of our collaborators, a psychologist, added that he would like to see that neuropsychological evaluations be done routinely, especially to assess executive functioning, and which means many of these tasks that are being measured, and something called response inhibition, again, distracted, impulsive. And on a more practical level, for children, if you have children, you could ask for supports that are similar to those, and I think this was already known, for other children who have similar difficulties such as ADHD. So again, this reinforces what was known. It may not be groundbreaking, but some of the fact that we can measure and it's really reproducible is actually very useful for future trials. And in our current trial, we're taking everything that was done for natural history and then doing more. So this is really a wonderful foundation for everything we're doing. And I know some of patients here are on both, or have been on both, so thank you. So in summary, our natural history is probably biased towards the best case scenario. These are motivated patients who are going to excellent centers and are really trying to do everything right. But it is very hard, as you know much better than I do, to maintain those, to lower those homocysteine levels with the current treatments. And so it does highlight the need for additional treatments, and we're trying really hard to do that. So we will be continuing to look at this data and publish it when we're finished doing the analysis. But again, skeletal fragility some cognition difficulties, some less ocular deficits or eye issues than in the past, and perhaps some signs of inflammation and dysfunction in protein and liver metabolism. And again, the hypermethionemia, so high methionine in about a third of the patients, both adult and children, was seen. So this was touched upon, and I didn't know that you were going to be discussing this, so this is a great tie-in. But I want to encourage all of you to continue to do this wonderful, these meetings and everything you do, because patients can really help the drug development process. And a few decades ago, patients were not so involved, but everybody, thankfully, has now realized that no one knows classic homocystinuria or any as well as you do, and there's so much you can do, and people really want to hear your voice, the patient voice. So again, you're doing everything right to forming the communities and encouraging and funding research, and even doing the participating in advisory, committees, or going to your legislatures to advocate for yourselves. I mean, that's very important. So thank you. And I would like to thank all the patients and their families who are participating in our trials. We really couldn't do it without you, and we really appreciate the effort that it takes. And also, again, it's You Network of America for everything that they're doing. I'm ready to take any questions if there's time. Okay, so thank you. Yes?
How do you solicit care providers to be part of your natural history? Like, my daughter's treated at Cincinnati Children's, and they have a metabolic clinic. Like, how would they become part of the natural history study?
So, sorry, right now we have those 6 sites in the United States. So you can certainly, I have flyers on the table outside you can take, and there's also an email address you can email us, and we can help you. So both by contacting your physician directly, but also contacting us, we can try to facilitate. Right now, we can't open new sites necessarily. We might, but I can't guarantee we'll open a whole lot of new sites. But if you're interested, please get in touch with us.
And I just want to comment on how you chose the initial one, because I know it has some patient numbers.
Yes, so we tried to go where more patients were, and we expanded as possible. Doesn't mean there are not other sites, but hopefully there's enough sites you can find something relatively close, and we can also help with travel. So, yes?
Is this presentation something that could be shared with us to put in the hands of our metabolic specialists, or?
I suppose I'm not quite ready to, again, because this is evolving, the numbers may change, but let me think about how best to present. Again, there's a lot of information there. Yes, I agree that as a mother, I would like to be able to share.
It's preliminary, but just.
Exactly. Yeah, no, I'll think of a.
You might want to comment that some of those studies are research-based studies, and so they're not available in every institution.
Exactly. So for example, the NIH Toolbox is not available. We brought it to the institution. So this is not something you could ask for somebody to do. But just bringing to the attention some of the findings might be something interesting to do.
Are there any abstracts already published?
We have plenty. I believe we have them on our website. If not, we will. So we have posters that we published in 2018 and 19 covering some of this information, actually most of it, because I just presented this in September, so it's pretty fresh.
So you can get it on our website. It may be there already.
Yes, so we could do that. That's actually probably the best way. One page, and kind of a take-home message. Yeah. Yes?
How long until you're done with the study?
So it's a 3-year study, meaning that patients go for 7 visits, every 6 months. As I mentioned, some patients are already in their 5th, so they'll be finishing the study, but we just enrolled some, I don't know, 1 or 2 months ago. So it will continue, and we intend to continue enrolling for a bit. So it's,
Tried to do it, but it didn't.
yes, and some patients, it's very hard to,
Far away.
it's too far away. No, I completely understand, I mean, yeah. Any, yes, please?
I'm curious, what forms of treatment have been initiated for the treatment of osteoporosis?
And repeat the question for the.
So what forms of treatment are available for osteoporosis, for
Yes.
example? Again, I'm not a medical doctor, I can't.
Kim can talk about
But Kim is coming next, so maybe she can, or would you like to respond now?
She's presenting next.
Yeah, so, but,
Maria,
yes.
I noticed, and maybe this is something Kim can address as well, is there's a flag for inflammation. So that seems to be something that is shown across your data. Is that?
We're definitely looking into this. Oh, yes.
Yeah, sorry.
So inflammation, there's signs that some patients, again, not all patients, may have elevation in inflammations, which could be a precursor to, for example, any cardiovascular issues. So we're looking into that, trying to understand. But again, keep in mind, all of this is averages. We're not looking at individual patients. We're looking at all 58 together. So with that caveat, yes, it is interesting, and it is not unexpected as well.
And will you look at the data over time to see if certain conditions cross-link, if you will, or maybe relate?
So yes.
So if inflammation is showing up some other...
So over time, are we looking at this data? So like I mentioned, this is a 3-year study, and we measure these every 6 months. So we are looking at also the variability. Sometimes we see patients that are high one visit, and not high the other. So that's also important to understand. What we're looking then are all the data together. Does inflammation correlate with something else? Is it related to something else? And again, we can't say for an individual patient, but it can give us clues about things to look for, or as also for us is very important, what else do we need to measure? Maybe we need, for example, the NIH Toolbox, there's certain, they're called domains, so, little bits of iPad activities that may be more interesting to do 2 or 3 different assessments for that. So this is all to better understand what we should be measuring. Yeah. Anybody else? No? Well, thank you so much for your attention.